Okay, today we did Module 3 list of 5 and subtract fractions with unlike units using the strategy of creating equivalent fractions. So we're going to use the same strategy we used yesterday when we were adding fractions, subtract fractions. In our first example, it shows 5/6 minus 1/3. And I'm going to take, and I like writing the fractions right above the one I'm modeling. And I always like putting the operation between them. Now the first one says 5/6, so I'm going to go ahead and split this into 6. There's 1, 2, 3, 4, 5, and 6. It says 5 of them, so I know I'm going to shade 5 of them. There's 5 out of 6 shaded. Now 1/3, I'm going to come horizontal and I'm going to split this into thirds, and then I'm going to shade 1/3. Now that we have it set up properly, we know that we're going to combine our models, and we're going to split our fifths into thirds, and we're going to split our thirds into fifths. Now we can see this fraction here. We end up with, we have a 1, 2, 3, 4, 5, 6 across and 3 down, so we know that's 18. So we have a denominator of 18, and we have 1, 2, 3, 4, 5 by 3, so we got 15/18 minus our 1/3. We are also going to have 18. We count up the squares, and we have 1, 2, 3, 4, 5. 5 out of 18, which equals 10 minus 5 gives us, 15 minus 5 gives us 10, 18th. Now it says up here to simplify your answer if possible. So we have 10/18. The way I like to simplify is to pull out factors. So I can see both of them are even numbers, so I know they have factors of 2. So I'm going to go 2 times 5 and 2 times 9, because 2 times 9 is 18. If I take out the common factors, I know my simplified form is 5/9. On B, we're going to model 2/3 minus 1/2. So we're going to split our first model into thirds, and we're going to shade in 2 out of 3 since it is 2/3. Our second model, we're going to go horizontally, and we're going to line out 1/2. Now we're going to split our thirds by half, and we're going to split our half by thirds. Now we can see we have a common denominator of 6. We have 4/6 minus 3/6, which equals 1/6. Since this is a unit fraction, meaning there is 1 over a number, that means it is in simplest form. On C, we're going to be taking 5/6 and we're going to subtract 1/4. So we're going to split this one up into 6. And we are shading 5 out of the 6. Second one, we're going to split vertically, and we're going to split this into halves, then into quarters. And we're going to shade in 1 for 1 out of 4. Now we're going to combine our 6 with our fourths. And over here we have our fourths, and we're going to combine that with our 6. And we're subtracting those. So we can see here now we actually have 6 by 4, so our common denominator is going to be 24. And we can see we have 1, 2, 3, 4, 5 by 4, so we've got 20 24ths minus 1, 2, 3, 4, 5, 6. So when we have 6 shaded out of 24, 20 minus 6 is 14 24ths. Now they're both even, so I know they're not in simplest form. So I know I can take 2 times 7, which is 14, and 2 times 12, which is 24. Take out our common factors. We know our reduced form is 7/12. On D, we have 4/5 subtracted from subtracting 1/2. So we're going to split it up into fifths. And we're shading 4 of the 5. We're going to split this one in half. We're going to shade 1 of the 2. Now we're going to combine our halves with our fifths, and we're going to combine our fifths with our halves. So now we have a 5 by 2, so we know this is common denominator of 10, and we have 8 out of 10 shaded. Minus here we have 5 out of 10 shaded, which gives us 3/10. E, we're taking 2/3 and we're subtracting 2/5. So we're going to split this first model up into thirds, and we are shading 2 out of the 3. Second, we're going to go horizontally, we're going to do fifths, and we're shading 2 out of the 5. Now we're going to combine our fifths with our thirds. And over here we're going to combine our thirds with our fifths. Now we can see we have 1, 2, 3, 4, 5 tall by 3, so our common denominator is 15. We have 10 out of 15 shaded. Minus here we have 6 out of 15 shaded. When we subtract them, we're going to get 4/15. Now we have one even and one odd number, so we know that it's not divisible by 2. They're not divisible by 3, and 4 is not a multiple of 15. 15 is not a multiple of 4, so we know we're in simplest form. Coming to F, now it's going to start getting harder because we're getting more and more larger denominators. So we've got to split this one into sevens. There's 1, 2, 3, 4, 5, 6, and 7. And we're shading 5 of these. 1, 2, 3, 4, and 5. Over here we're going in thirds, and we're going to shade 2 out of 3, because this was 2/3 and 5/7, and we're subtracting them. Now we're going to combine our thirds with our sevenths, and we're going to combine our sevenths with our thirds. One, 2, 3, 4, 5. Got one more in here. Okay. So now we know we have 7 by 3, so our common denominator is 21. And we can see we have 3, 6, 9, 12, 15 out of 21 shaded. And we're subtracting here, we have 2, 4, 6, 8, 10, 12, 14 out of 21 shaded. So we can see 15 minus 14 gives us 1/21. It's a unit fraction, so we know it's in simplified form. 4. Katrina needs 3/5 kilogram of flour for a recipe. Her mother has 3/7 kilogram of flour in her pantry. Is this enough for a recipe? If not, how much more will she need? Okay, so basically, first thing we're going to do is we have 3/5, and it says she needs 3/7. So I'm going to combine these to compare them. And I'm starting off by splitting this into fifths. And we're shading 3 out of the 5. Now there's other one we're going to do 7. There's 1, 2, 3, 4, 5, 6, and 7. And we're shading 3 of them. Now we're going to be combining our 7s with our fifths. And over here we're combining our fifths with our 7s. Now we know with 7 by 5, we're going to have a common denominator at 35. And we know this is 1, 2, 3, 4, 5, 6, 7, and it's 3 rows, so it's going to be 21 25ths. And over here, we have 1, 2, 3, 4, 5 by 3, so we have 15 35ths. Okay? Now, I'm going to do a diagram here. And I know the total here is what she needs is 21 35ths, because that was equal to 3/5 kilograms. She has 15 35ths. So, yes, she has enough. So she doesn't need any more. Next one, for the following problems, draw a picture using a rectangular fraction model and then answer. So now we're getting back to the whole numbers again. Now we're going to take 1 and we're going to subtract it from 5, 6. Well, if you notice, if I were to change this whole number to 6, okay, and we would have to shade them all in. And if I took away 1, 6, or 5, 6, I would only have 1, 6 left. Now this wasn't a mixed number, this was just a whole number. So it was easier to do this way. Now our second one, we have 3 seconds. Well, 3 seconds I know would be 2 seconds plus 1 second. And we're going to be subtracting 5, 6 from it. So 2 seconds, I know I'm going to put it here, and I'm going to shade both of them in. This one I'm doing half, and I'm going to shade half of it in. Next one is 5, 6, so I'm going to split it into 6. And we're shading 5 out of the 6. Now we're going to combine them. I'm going to cut my halves into 6. And my sixths, I'm going to split into half. So over here, I know the 2 seconds. Now we have 1, 2, 3, 4, 5, 6. So we actually have 12 twelfths here. In half, I'm going to have 6 twelfths. And we're going to subtract. Over here, I've got 2, 4, 6, 8, 10 twelfths. When I add these together, I end up with 18 twelfths minus 10 twelfths, which is going to give us 2 twelfths. Now, 2 twelfths, I know I can go 2 times 1 over 2 times 6. So I can take out the common factors, and I know that I have 1/6 in simplest form. Okay, on C, we're doing 4/3, so we're going to split everything up into thirds. And I know that this is going to be 3/3 plus 1/3, which gives me 4/3. And I'm going to be subtracting 5/7. So I'm going to go ahead and split this up into thirds. And I know I'm shading everything in on this one. And over here I'm going to thirds. I'm going to shade 1 out of the 3. Horizontally on my next model, I'm going with 7ths. There's 2, 3, 4, 5, 6. and 7. And I'm going to shade 5 out of the 7. There's 2, 3, 4, 5 out of the 7. Now I'm going to combine my 7s with my thirds. There's 1, 2, 3, 4, 5, 6, and 7. And over here I'm going to combine my thirds with my 7s. Now over here I know I got 3 by 7, so this is going to be 21 21st plus here I've got 1, 2, 3, 4, 5, 6, 7, so I know this is 7 21st. And we're going to be subtracting. Here we know it's by 21st, and we have 5 by 3, which is going to be 15. So 7 plus 21 gives us 28 21st minus 15 21st, which will give us 13 21st. Now 13 is a prime number, which means it only has a factor of 1 and 13. So as long as 13 is not 21 is not a multiple of 13, we know this is in simplest form. On D, now we have 1 and 1/8, and we're subtracting 3/5 from it. So we're going to be splitting them into eighths, since the fraction with a mixed number is an eighths. There's 4, 5, 1, 2, 3, 4, 5, 6, 7. I'm going to have to sneak another one in there. I'm just going to draw it out to the side because it's going to be too big. Okay. Now this one here, we're doing eighths. There's 1, 2, 3, 4, 5, 6, 7 eighths. And this one, we know it's all going to be shaded in because it's a whole. And we're going to have 1/8 shaded in. Now on this side, horizontally, we're going to go with fifths. There's 1, 2, 3, 4, 5, and we're shading 3 of the 5th in. Now we're going to combine our fifths with our eighths. As you can see, the larger the denominator, the harder the model gets. It's 1, 2, 3. That's 1, 2, 3, 4, 5, 6. There's 8. Now we know that all of this one is shaded in. So it's going to be, we know it's 5 by 8. So it's going to be 40 40ths plus, we have 1/8 was shaded in. So, and that was, we know that the common denominator is 40ths. So that's going to be 8 40ths minus, over here we've got to combine our eighths with our fifths. So we're going to end up with, we know that the common is 40ths, and we have 8 times 5 is going to be, 8 times 3, which is going to give us 24 40ths. So now we have 48 40ths minus 24 40ths. When we subtract this, we're going to get 24 40ths. Well, once again, 24 40ths. I know these have factors, both have, or factors of 4. The factors of 2, but I know 4 will also work, and it's a larger factor. So I know this 4 times 6 over 4 times 10. Take out common factors, and I still have 6/10. And I know these both have factors of 2, so I can do 2 times 3 and 2 times 5. Take out the common factors, and our simplified term would be 3/5. Okay, on E, we have 1 2/5 minus 3/4. So I'm going to start by modeling, and I'm going to split my first 1 2/5, and we're subtracting 3/4 from it. So I'm going to start by, and I'm going to put my 1 in fifths, and they will all be shaded. And then I'm going to do 2/5 on this side by splitting it into fifths, and I'm going to shade 2 of them. Now my 3/4, I'm going to go horizontally, and I'm going to do fourths. And I'm going to shade 3 out of 4 of them. Now I'm going to combine my fourths with my fifths. And I'm going to combine my fifths with my fourths. Now, since we did 5 times 4,
the special events committee will meet in the family resource room.
we know we're going to have a common denominator.
Right now. So the special events committee will meet in the resource room, the family resource room. Thank you at 3:15. Thank you.
So our common denominator is going to be 20. And this is going to be, since it's one whole, it's going to be 20 20ths. Plus, we can see we have 2, 4, 6, 8, 8 20ths. And we're going to be subtracting. We know this is 20ths. And these are 1, 2, 3, 4, 5. So it'd be 15 20ths. We add these together. We end up with 28 20ths minus 15 20ths, which will give us 13 20ths.
Last call for back gate. Last call for
now 13 is a prime number, so it only has a factor of 1 in itself. So unless 26 is a multiple of 13, is in simplest form, and it's not, so it is in simplest form. Our next problem, we have 1 5/6, and we're going to subtract 7/8. So we're going to split them into 6. And we're going to shade in all 6 of them.
Nick Newton, your conference is in the front office.
The second we're going to do fifths. There's 1, 2, 3, 4, 5, and we're going to shade 5 out of 6. Second one is an 8, so we're going to do this into 8s. And it's 2, 3, 4, 5. Say 1, 2, 3, 4, 5, 6, 7, and I'm going to have to add 1 on the bottom down here. 8. And we're going to be shading 7 out of the 8 of them. 4, 5, 6, 7 out of the 8. And as you can see, when you start getting to larger denominators, the more difficult it gets to represent. Now we're going to combine our 8s with our 6. So there'd be halves, quarters, and 8s. Halves, quarters, and 8s. On this one, we're going to be doing our 6. So here we have thirds, and we have 6. Now, it's hard to see with all this, but we know this whole here, and we did 6 and 8, so 6 times 8 is 48, so we know our common denominator is going to be 48. And this is going to be 48 48s, plus here we had 5 out of 6, so that's 5, going to be 5 times 8, it's going to be 40 over 48. And we're going to be subtracting 7/8. And we can see this is 1, 2, 3, 4, 5, 6. They're 6s. Okay. So On this one, we're going to have 48, and it's going to be 42 48ths. We add these together, we're going to get 88 48ths minus 42 48ths, which is going to equal 46 48ths. Now that is not in simplified form, so 46 48ths, if I didn't know what a good factor was, I know they're both even, so I could start with 2, and I know 2 times 23 and 2 times 24. Take them out, and I end up with 23 24ths, and I know it's in simplest form just because they are only 1 unit away from each other between numerator and denominator. So in simplest form, that would be G 23 24ths. We're doing 9/7, so I know this is going to be 7/7, and over here we're going to have 2/7 because 7/7 and 2/7 equals 9/7. 2 3/4. We're going to be subtracting that. Now 7, so we're going to have 1, 2, 3, 4, 5, 6, 7, and we're going to put these into sevens. 1, 2, 3, 4, 5, 6, 7, and we're shading 2 of 7. Now we know on the whole everything's going to be shaded in. Okay, now horizontally we're going to do fourths. 1, 2, 3, 4, and we're going to do 3 out of 4. Now we're going to combine our fourths with our sevenths. And we're going to combine our sevenths with our fourths. Now we know 4 through 7, so that's going to be 28. It's going to be our common denominator for all of them. Now this one's totally shaded, so it's going to be 28 28ths, plus over here we had 1, 2, 3, 4, so we're going to have 8 28ths. And on this one we had 1, 2, 3, 4, 5, 6, 7 times 3, so it's going to be 21 28ths. And that's what we're subtracting. We add them together, we end up with 36 28ths minus 21 28ths, and we'll get 15 28ths. Now this is where we got to try to see if we can find a common factor. We know 2 and 4 are not going to work because they're not both even. So 3 is a multiple of 15, but 3 is not a multiple of 28 because I know 3 times 9 is 27. Okay, so 5 is not, because it's going to be ended either 5 or 0, and 28 does not end in 0. And 7, which is a prime number, is not a factor of 15. So 15 28ths is our simplified form. Now our last one here is 1/12. Now this is where it really starts being hard doing a model. Okay, so let's try something a little different on this one. We know if we do this in 12ths, 1 whole is going to be 12 12ths and 3 12ths. And we're going to subtract 2 thirds. Okay, well, if we add these together, I have 12 12ths plus 3 12ths. That's going to give us 15 12ths. And we're subtracting 2 thirds. Now, using what we did with equivalent fractions, if I took 2 thirds and I wanted to make that into 12ths, what would I have to multiply that by? Well, I know 3 times 4 is 12, and since I want to keep it as multiplied by 1, we go 4 times 2 is 8. So 2 thirds would actually be equal to 8 12ths. So 15 minus 8 would be 7, and 12 minus 12 is 12, because it's Our answer is 7/12. This is what we want to get to, is using the abstract. Okay, as you can see, once you get up to very large new denominators, the models become very difficult. 2. Sam had 1.5 meters of rope. He cut off 5/8 meter and used it for a project. How much does he have left? Okay, so I can see we have 1.5. Says he cut off 5/8. Now if I look here at a tape diagram, it says this here, which is 1.5 meters, says that he cut off 5/8, and he wants to know what is left. So this tape diagram helps us determine what we need to do. So we can see we need to subtract 5/8 from 1.5. So we can see we're going to put this into halves, and on this one we're going to shade both sides. On the second one we're only going to shade half. Now we're doing 5/8, so I'm going to cut this up into eighths. There's 2, 3, 4, 5, 6, 7, and 8. And we're going to shade 5 out of 8. There's 1, 2, 3, 4, 5 out of 8. Now we're going to carry our 8s across, so I'm going to cut these in half. Then I'm going to cut them in half again to where it would be fourths. Then I'm going to cut them in half again, which would be eighths. Now we know 2 by 8, this is going to be 16, and for just a whole number, it's going to be 16 sixteenths, plus 1/2, which is going to be 8 out of 16. And we're subtracting, well, we haven't cut this one in half yet, because we have half, we need to cut it in half. And we know we had 5, so we're going to end up with 10 sixteenths. That's to be a 10. We add them together, we got 24 sixteenths minus 10 sixteenths, which equals 14 sixteenths. And we can reduce that because we know 2 times 7 and 2 times 8. So that means he has 7/8 meter left. So how much does Sam have left? He has 7/8 meter left.